Okay, guys. So thank you for joining our third class on Databricks. So what we will do today, uh, we will just understand the basics of Spark, very basic of Spark, and then what we will do, we already made the data lake, right? So we will understand how to mount. So we will start on basically the data source API of Spark, and which means we will understand first of all how to mount, so that we get at least get a feel of how things run in Databricks. So how to mount a container in Databricks, and then uh, we will try to read a CSV file. We will try to read a CSV file and properties, like what are the things, what are the parameters we need to take care um, while reading the CSV file, right? So property of reading, yeah, and property. Read CSV file and its property basically. So yeah, so this is what we will do today. Till now, what we have learned, till now we have learned basically what is cloud, how many types of cloud, public cloud, private cloud, hybrid cloud, then IaaS, PaaS, then we understood about resource group, then we understood about subscription, then we understood about management group, then we also went into and made um, tenant, right? And in the tenant we understood how to add a user, all the basics of like just getting started with Azure. Then we understood why database is important, what are the different features of the Databricks, right? And then we also understood very very important interview question, what is the difference between a blob storage and data lake gen 2. So difference between a blob storage and data lake gen 2 is, in data lake gen 2 you can make a directory inside a container, which you cannot do in the blob storage, and also you can manage ACL, access control list, in data lake gen 2. And data lake gen 2 is recommended for big data analytics workloads, which you cannot do in the like which ideally the blob storage is the older version of solutions. All of this we have understood, right?
Okay, right.
So now
Yes.
let's start with very basics of a Spark.
Mm.
So whenever we are learning about, I will mute all of you. So if you have any question, please unmute yourself and ask the question. Okay. So whenever the data, why there are five V's of big data. So you will get this particular term everywhere. So when we call a data big data, right? So when a particular data has like a huge volume, and then it's coming in a like a variety of formats, like we have a JSON format, we have a CSV format, many different file format, right? And then data is generating in a like in a faster manner. So suppose the data is coming in a batch manner as well, in the stream manner as well, right? And then whether we are able to get the value from that particular data, right? So whether that data is providing us any kind of a value, and then do we have like we shouldn't have the inconsistency in the data, right? So there should be like certainty in our data, that data looks good whenever you are uh, basically doing the aggregate or any kind of aggregation which you are doing. So these are the five V's of the big data. Whenever a data is growing, right? So we need to take care about the volume, we need to take care about the variety, and then we need to take care of the the data which is coming at a very high pace, whether it's providing the value or whether it's giving us the value with certainty, right? So all of these are the five V's of the big data. Now, in the past days, we have like SQL database in which like yeah, so we have two kinds of data in general. So we have the data which is in the SQL format, right? The relational data. So in the relational data, we run a SQL query on top of a relational data, and then we basically get the value out of it, right? And then to store the NoSQL data, we have the Cassandra, the MongoDB, where we basically store the NoSQL data, right? So these are the two main file format of the data, and then your when you have the big amount of data, it comes in both of the file format, in your SQL file format, in the NoSQL file format as well, right? And when it comes to like the old days, we have like Hadoop, in which we process the data in the distributed manner, and basically in the SQL, what happens is see. So what's the problem in processing the data with SQL, right? So in SQL we can process data, but in SQL the whenever you are processing the data, it won't be processed in the distributed manner, right? So SQL cannot scale. It can scale vertically, but it cannot scale horizontally, right? You can just increase the computing power of your SQL database, but it cannot like scale vertically. It cannot just scale vertically, as in like you cannot just divide your particular processing in different distributed manner, right? So that is a problem with the SQL. That is why which like Hadoop solved it. So in the past days we used to use Hadoop, right? In Hadoop we can do the distributed processing, which means it has a master slave concept. So whenever you want to process any sort of a data, you basically like submit your job to the master, and it will divide your job to different worker node. Okay, so your job will be divided to different worker node, and then your processing will happen, right? So it has a master slave concept. You have a master node, and then whenever you are submitting your job to the master node, that particular master node will divide your data to different slaves, and then those slaves will basically process your data, and then the result will be given by back to the master node, and then master node will give you the result, the final result, right? So that was a Hadoop before, but the main problem with Hadoop MapReduce is we don't need to go to into the details of how MapReduce works and all of that. But the main disadvantage of Hadoop, which basically Spark solved, is in Hadoop it does the disk processing. Okay, so what in a very simple terms, what and in Spark in memory processing happens. Okay, what does it mean in very simple terms? So suppose if I want to write the phone number, if you ask me to write my phone number, the phone number to if you ask me to write the phone number of um, any of my like the far relative. Okay, so I just need to go to the my diary or my phone log. I will search the number, and then I will give the number to you. Okay, suppose if you just ask me the number of any of the far relative, but if you just ask me my own phone number, or my own phone number, or my very close relative phone number, that phone number I remember it. Okay, I don't need to go to the desk and go somewhere to fetch that particular data, and then particular give you the result back. So the main problem with the Hadoop is it's basically it does the disk processing, right? So that's the main problem which Spark solves. It does the in-memory processing. So with Hadoop, whenever you're processing any sort of a data, suppose the whole processing takes 15 minutes, so read write operation will itself take like 10 minutes of you, because it basically retrieve the data from the disk, then process the data, and then it will write it back, right? So that is why Spark is basically much more faster than Hadoop, because of this particular advantage, in which Spark does the in-memory processing. In-memory processing means, yeah, so your data will be there in memory, and then it does the in-memory processing. It basically divides your data to different RDD, which we will see going forward what is RDD and all of that, but it will basically divide the data to RDD, and RDD is also a building block of Spark basically. So whatever you are processing in Spark, it will be divided into RDD, and then the processing will happen. Okay, so it is a building block of RDD which was not there in the Hadoop as well. But the main advantage of Spark, it does the in-memory processing compared to Hadoop, right? And how the processing happens in Spark, whenever we submit a job in Spark, right? In whenever we submit a job to a cluster manager, it divides the data to different RDD, and then RDD will be converted into the task, right? Different task, and then processing happens, and then it will be given to different worker node, and then the processing will happen. We will go to this diagram in a detailed manner. We will understand what is DAG, how it is converted into RDD, what does how the task looks, right? All of this we will understand, but in the nutshell, we should we should now understand we should understand now that Spark basically does the in-memory processing. It does the processing based on master-slave concept, which is similar to Hadoop, but it does the in-memory processing. Whenever you submit the job in Spark, it first goes to the driver program, and then that particular job will be converted into RDD, and then the processing happens by using different worker nodes. Okay, and after processing and after worker node basically processes the whole data, it will be given back to the driver program, and then you get the final result, right? So this is how the processing happens. Just like I just give this example multiple times. So if you want to count coin which is present in a box, if you are the only person who's counting it, you might take time, but if you just divide that particular task to many of the worker, your counting will become fast, right? So yeah, so whenever you submit any job to the driver program, it will be divided to different it will be assigned to the worker node, and then worker node basically process your data and then given back to the driver program, right? Now in Spark, we have, yeah, so as I told you that Spark basically build on RDD in general, and it has different APIs, okay? Because Spark at the same time is library rich, which I also told you in the past that Spark is library rich. It offers you different APIs to work with different language. Using Spark, you can ideally work with Python, you can work with SQL, which means in Databricks, you can write PySpark, you can write Spark SQL as well. And beside that, you can write R and Scala language as well, which, yeah, so those language as well you can write. But mainly in the industry, people uses a PySpark language or Spark SQL language. Okay.
One
So,
question, Abhishek, sorry to
yeah.
interrupt. So basically, Spark is doing in-memory processing, right? Like on, or like Hadoop used to be also in-memory processing, if I'm not mistaken, no?
Hadoop used to be the not in-memory processing. Hadoop used to be the like it patches the data uh, from the memory and then process data. So Hadoop not used to be in memory processing.
Okay, and in memory processing, in the sense like it's so for example, the data while it is getting processed, and from any of the source system, it will be stored in RAM. If RAM, then we need a very heavy machine, right? Like which should have, I think, good capacity of RAM inside it.
So whenever you define the cluster memory in the Spark, you basically define. So suppose if I'm processing the 10 GB of data or 20 GB of data. So based on how much data I am processing in Spark, I will define my cluster memory with respect to that itself. And if that memory exceeds, then it will again use the in-disk memory for like storing the data or for compute for the data computation. But whatever data you want to process, so suppose if I want to process 20 GB of data or 30 GB of data, your cluster size should be more than that, or it should be equal than that actually.
Oh, okay, okay. So basically, like it's basically also processing in the RAM plus SSD or HDD,
Yeah,
whatever
if
we have.
but in
Okay,
general we don't we try not to use the SSD memory. We always try to use the like in memory RAM processing itself, because that is what Spark uh, does, right? And that is why
yeah,
it's whole reason of using Spark.
all right.
Yeah.
Thanks, thanks. Can
And
we?
Spark is
Yeah,
basically faster than Hadoop
right.
because it performs the in memory processing, and Hadoop uses a map reduce which intermediate the data to the disk, right?
Right.
So that basically makes Spark better, and also at the same time Spark provides you the API in Java, Scala, Python, R, which is easier to use and more versatile than Hadoop. So yeah, so and Spark is also at the same time, in Spark you can do streaming and structured streaming, which allows you to do the real-time processing as well. And in Hadoop you have MapReduce framework, which is for the batch oriented, not basically designed for the real-time processing. Yeah, so those things are better in Spark, and that is why Spark is yeah much more faster than Hadoop in general.
Right. And one more question. Thank you for that. So first is like this PySpark. So PySpark, I assume is a Python. So we basically create data frames. So within data frame, the data will be imported from the source system, for example, and now it will be processed. So
Mhm.
data frame will run on this in-memory computation. But how
Yeah,
about the SQL Spark, like SQL Spark?
in
Because mhm.
Spark SQL as well, you
Yeah,
will basically whenever you are running a SQL query, you
yeah,
will load your data in a data frame itself, which is PySpark data frame. Sorry, Spark SQL data frame, and both the data frame is same, right? So whenever you are basically running your SQL query, which I will show you,
yeah.
so you will also load the data to a data frame itself, and then on top of a data frame, if you want to write a SQL query, you can convert that data frame to a view, and then you can write a SQL query on top of it.
Okay, so basically you are telling that Spark SQL is faster than if you are
No,
running any query
I'm not
on
saying,
database. Mhm.
yeah, so Spark SQL or PySpark from the speed perspective, we it's not that PySpark or Spark SQL anything is faster. It's just a way of convenience what you want to use. But both you will use in both you will basically use data frame itself.
Okay, like if I write a merge statement in Spark SQL or merge
Hmm.
of two data sets, and
Hmm.
if I write a merge statement on database backend, like on database, I'm running into two tables through two tables via lookup. So Spark is much better than running a query on the database engine, right?
Yeah, so Spark is better than running the query in database. It depends, right? So you cannot just So suppose how much data that particular data frame or that particular data contains. So suppose if you just take small data and then if you run it in normal SQL database or in Spark, both might give you the same performance. But if you take both the data, a big amount of data, both the data having like suppose 1 million or 2 million of record, and then if you run a join query in Spark, and then if you run a join query in SQL, Spark will give you the better performance. It depends upon the size of data as well. At the same time, I was telling that writing a query in PySpark or writing the query in Spark SQL, there is no difference.
There is no difference, yeah.
Yeah, so there is no difference. But if you want to write a query in SQL and if you're writing a query in Spark, definitely Spark is better. That is why we are learning Spark right now, right?
Okay, yeah, exactly. I mean, just
Yeah.
was just trying to compare.
Yeah.
Thanks. Yeah,
So
thanks,
if
Abhishek.
you are, and also at the same time, there is a, so also it's a, sometime there's a misconception that Spark SQL is slower than PySpark, or PySpark is like, there is no such thing from the speed perspective. Now, like which language to prefer, that also sometimes people have a confusion. So the thumb rule is we will never write a Python query in Databricks. We will write it whenever it's needed. It's required to write it because that particular API you don't have in PySpark. So Spark doesn't offer that API so that you can do certain tasks such as some of the visualization task. Python does it better, which you don't have in PySpark. So in that case, you will use PySpark, but you don't write Python. So you will not use Pandas data frame in Databricks. So that is the rule number one. Okay.
Right.
Now, when we should write a PySpark or when we should write a Spark SQL. So let me. So Python is no for Databricks, which means like Pandas data frame or Pandas we will not use, okay, in Databricks. Though people use it for some cases, but it you are not using the Spark capability in that. And then people are sometimes confused which language to use when it comes to PySpark or Spark SQL. Now, this is the matter of choice, which language you are more comfortable with. So people sometimes are comfortable with SQL, so they prefer Spark SQL. Sometimes people are more comfortable with Python, so they use PySpark. Okay. Now, if you're learning with, if you, and I guess from the whole, our whole class is more of a SQL centric. Okay. But I suggest you guys, it's good that if you're SQL centric, you can write your code in Spark SQL as well. But try to learn Python as well at the same time. Reason being, Python is a better language when it comes to maintenance of your whole code. Why it's better? Because you can create multiple function. You can basically call those functions. So suppose if I have written a particular function in Python, which is joining two data frame and then doing the aggregate of that data frame, and then after the aggregation it's providing me some result. Okay, that function I can write in Python, and I can just like use this function many times anywhere else, right? But uh, Spark SQL is not so handy when you want to maintain the code, and also it's not so handy when you want to write a unit test on top of it. Because Spark SQL, like suppose if you're joining 10 different tables, then it's much better in Python than SQL, right? Now, now again you can ask me that, Abhishek, if it's better, why people choose to write Spark SQL? I should write always Python, right? In that case, now, uh, like, yeah, you should write. It's better if you write PySpark code always, but sometimes it's not uh, like it's not easy as well, right? Suppose if I will just give you a scenario in which scenario it is not easy. Suppose we are all together working in a project, and we all know SQL. Okay, now now we basically need to deliver a project in a 1 month. Okay, now our whole team efficiency will be better if we just write our code in SQL, right? Because we all know SQL, so our whole team efficiency will be better. So what we will do, we will write the whole code in SQL and then we'll deliver it. We'll just so from the efficiency perspective of a team, it will better. And then second is, suppose if I have a stored procedure written in legacy system, suppose if I am doing the data migration project, and if I am, my whole code is written in legacy system which is SQL database. Now my manager came to me and asked me that, Abhishek, move all of this stored procedure to Databricks, because we don't want to use SQL now. We want to use Databricks now for because our data is increasing and all of that. So what I will do, I will create those tables in Databricks environment, and I will just copy all the stored procedure. Like there is 100 stored procedure are there, so I will just copy those stored procedure and try to use the same stored procedure in Databricks directly, instead of putting some effort to convert those SQL stored procedure, the big SQL stored procedure, to PySpark code. So that is why also in that way as well, the Spark SQL is better. So yeah, so it's just a way of like which language is more convenient for you, and at the same time which language is like more suited or better for now, right? So yeah, so but both language are widely used, so there is no doubt about it. And at the same time, there is a code which you can write in Scala and R as well. Sometimes I will also use a Scala here and there, because that is how the notebook is arranged and all of that. But the Scala is less used. So my recommendation to all of you is, don't think from the law language perspective. Reason being, language is anyways easy way out. I being a developer, I'm not so concerned about the language. Reason being that there are so many Chat GPT, Gemini, and now Databricks also has a AI assistant. So if you just write a SQL code, that can be converted into PySpark. A PySpark code can be converted into SQL. A SQL code can be converted into Scala. So language is not a issue nowadays. Try to learn concept. Try to learn how Spark works, and try to just understand the, if you give this input, what logics you can write to receive that output, and language won't be a issue in the end, right? So don't too much be worried about which language to use and all of that, right? Okay, guys, so that's all. Now what we will do, as I was explaining in this particular slide, so Spark has different API, right? So it everything is built on RTT, and then it has like your data source API, data frame API, okay, uh, and then it has data set, data frame, all of, right, all of that, right? So yeah, so you basically, it has data source API, data frame API. Now in top of RDD they build data frame API, data set API as well. So there is also an important interview question: what is the difference between RDD, data frame, data set, which we will learn going forward. But for now, let's try to get a feel of it, and just let's start with the data source API of the Spark. So if I go to Spark,
Abhishek, just one question. Sorry to
yes,
interrupt.
yes.
How the work will be distributed among different worker nodes? Do we have any specific rules, or how it will be distributed?
Uh, how the work will be distributed in the, so there is no specific rule of it. But like how much memory each worker will take, like that there's some calculation about it which I will share going forward. But you in Spark, you will not mention about the worker configuration. You don't do the worker configuration in Spark. You generally just submit your job to the driver node, and it basically takes care of things automatically. You don't mention all the, like the worker memory and all of that in Spark in general. So yeah, so there is no rule as such for that.
Okay, thank you.
But going forward, I understand, like I can totally sense that yeah, there is a curiosity of how the work is distributed, and so I don't want to go right now in too much of a detail of those things, because it might confuse you in beginning, because I just want to give you the feel of the environment, and then we will slowly touch upon the Spark
Mhm.
configuration and how things work there. But be patient, it will come. Going forward, you will understand those things as well. So
Okay,
yeah,
fine.
so
Yeah.
here if I go to the data source API of the Spark, so if you see, currently today we will, yeah, so today we will go through this particular JSON files, right? This particular thing which we will go through it, but data source has all of this API, right? So yeah, if you want to read ORC file, JSON file, CSV file, text file, if you want to get the data using JDBC connector, Avro file, how to read Avro file. So these are the different API offered by the Spark to do all of this manipulation. Today we will go through the how to read a CSV file. That is what we will go through it, because it's a CSV file is a very common standard format which we generally use. So we will go through this particular API first of all. To do that, we first of all need to import a CSV file in Databricks environment. Okay. So now one more thing which is very important to understand is in Databricks there is like so I already told you guys to make the community edition of Databricks. If you haven't made it, please make it. So today we will use this community edition of Databricks. I already covered how to make a community edition of this, right? I already covered that. So please make this particular account. So sometimes there is a confusion uh, that in Databricks, can we store the file as well? Yes, you can store the file, but it's not recommended to store the file in Databricks. Okay. Ideally, I can just upload the data over here. So if I want to read the data in Databricks, I can just upload the data over here. Yeah, so basically in Databricks, you can directly upload the data, which we call it as a Databricks file system, DBFS, right? That also can be done. But we use it for like doing for storing some of the file here and there. Like if you just want to store some of the file in Databricks file system, then you can do it. But Databricks cannot be your storage medium for your project. Okay, you will in most of the cases, in 99% of the cases, you will always rely on external storage, which is data lake in Azure terms. And suppose if you are working with Amazon, you will basically rely on Amazon S3 bucket. But it's not recommended to store the data in Databricks. Like I have done so many projects, but you never ever store and make Databricks as your main storage system. Here and there, if some files are there, it's okay. Okay. Sometimes you will see that people are not conscious about it, and then when you started working in a company, if you see that people are storing data in their Databricks file system, then it's they are not following the best practices. Reason being that when you store the data in Databricks file system, it's not easily you cannot easily download the file. You cannot easily migrate that particular data whatever you have stored. uh, it's not like basically whenever you store the data in Databricks file system, the different versions of your data is not being created. But if you do it in normal storage system, that you can do. And at the same time, data level of permission Also, you cannot manage because it's not basically a storage medium, right? So it's not recommended that you store the data in Databricks file system. So what we will do now, we will first of all understand how to mount our data lake and read the data from data lake to Databricks. What is mount? Mount is nothing but a one-time process to make connection of Databricks with your lake. So once you make your connection from Databricks to your data lake, ideally Databricks and data lake needs to connect, needs to communicate with each other, right? So to read the data from Databricks, you ideally need a connection of Databricks and data lake, right?
Yes, Abhishek.
1 second. And it's a one-time process. So what we will do here, we have a data lake over here, and we have so we will basically generate a key from data lake, give it to Databricks, through which we will authenticate the read or write permission. Okay, so we will get access keys, and once access key, or you can just say SAS token key, and then once Databricks has those access key, Databricks can basically, yeah, so it is authenticated, right? So once it has access key, it can read write the data through the data lake. Okay, so this particular data lake, we are using data lake right now in case of Amazon, but it can be different for different kind of a cloud. Okay, um, yeah, so for Amazon it will be S3 bucket, right? So but always and always Databricks use an external storage system to read the data, to write the data. If you want, you can store the data in database as well, but it's not recommended. Okay, now as I told you guys that in this particular group, this sample file and code link is there, right? Okay, so click in that particular link, and then you will, it will be routed over here, and it has many good material. So you have PPT, you have like if you just go to the interview question, you'll get many interview question, and whatever learning material I share in the community, I upload it over here as well. So it has a very good material. Now what you can also do is you can go to this Databricks sample code, and then download this particular sample code. Okay, what it contains,
So,
yes.
okay, sorry to interrupt. Okay. So, I mean, how the data will come to data lake? Is it a part of data engineer role, or someone will take care of those things?
It's a part of a data engineering role. So in Databricks, in data lake, the data will come from some sort of a orchestration, like it will come from the orchestration tool, which is Data Factory. So you will ideally use Data Factory for migrating your data from any kind of a source system, and then from using Data Factory, you can move the data to data lake. Yeah, so that you can do, and if you want to do it using Databricks as well, that is possible. It's not like you cannot do it, but you don't have a direct connector. So suppose in Data Factory you have a direct connector to connect to your source system and then move the data. So it's a part of um, the data movement. Generally for data movement, we either use Data Factory or Synapse Analytics pipeline to migrate your data from the source system to Azure Data Lake. But from the Azure Data Lake, once you have the data in Data Lake, yeah, so it's a part of data engineering, just to answer your question. And then you can use Synapse Analytics tool or Data Factory for migrating the data from source to Data Lake.
Okay, yeah, got it.
Okay, fine. So now download this particular DBC file. What is this DBC file? In this particular DBC file, I have kept some of the code which we will use during our sessions today and going forward. I will keep on sharing this kind of a DBC file going forward as well. So in this particular code, what you will find the code for the mounting purpose, and also some of the sample code is there which will use going forward. Okay. So once you download this particular DBC file, this DBC file is not given by Databricks, is not given by like Databricks, like it is not present in Databricks. What you need to do is you need to import this particular DBC file, right? Before doing that, let's understand these tabs. Okay, so here you have workspace. In normal account you have repos as well, which I will going forward, once we create a normal account of Databricks, I will show you how you can integrate repo, right? So you have workspace, then you have this particular shared folder, in which cases you use this shared folder. Suppose me and Venkat is working in a particular project, and Venkat created a notebook which he wants to share with me. So he can just go to the shared, like he can go to his notebook, and then like he can just share with me. That will come over here directly. Okay. Now here, as in this particular account I am the only user, so you are able to see over this over here. But if you have multiple user in your organization, then you will see the different user who is there in your organization. This is being used for any sort of a deployment. So once uh, you develop something, once you finalize something, and then once that code is ready, that code will be deployed over here, which we use for the orchestration and all of that, right? This is the workspace tab. This is the tab where you get the recent. This tab is only there for the community edition, but you'll get many other tab when you are using a normal account. This is the catalog. Catalog means once you read the data in the Databricks environment, if you want, you can create a normal table over here, which we will see going forward how to create a normal table. Yeah, so once you create a normal table over here, the backend of this data table, whatever table you create over here, will be data lake. Okay, so this is also a very big the confusion for many people, that if you store the data in catalog, if you store the data in Databricks, what should be the backend of it? The backend of those data points should be data lake in any case. Okay. Sometimes we store the data in Databricks file system as well, which is okay. As I told you that in some cases we do it because of the cluster configuration is not manageable and all of that. But best practice is the whatever table you create over here, the backend of those data points should be data lake. Okay. So once you start reading the data in Databricks, you are ideally using the data lake as your storage system, and you're fetching the data from the data lake, which is basically readable from here. So just like if you guys worked in like all of you are from the SQL background, so sometimes in SQL warehouse, particularly if you have worked in Snowflake and other databases, so generally in SQL as well you create your external table, right? So your basically your main storage is present somewhere else, and then you are trying to read and write the data. So in this particular catalog, if you create the table, ideally you can remember it. It's not there in Databricks file system. It shouldn't be there in the Databricks file system. The backend should be in data lake. But yeah, in few cases, you store the file in data lake as well, which in the Databricks file system, which is doable. Now, here you can basically orchestrate your data. What I mean by orchestrate your notebook. Suppose if you have written a notebook of which basically write the operation. So this particular workflow tab can be used to like to schedule your job, and then basically schedule a job at a particular time, and all of that can be done using workflow. Compute, here basically we create our cluster, right? So how many types of clusters are there and all of that we will understand, but mainly you can right now understand that from this particular tab that there are two kinds of a cluster in the nutshell. So all purpose cluster and job cluster. Okay, all purpose cluster is nothing but the if you create a cluster over here, it can be used for any kind of a case, right? So that is why we are saying is it as a all purpose cluster. Job compute is only related to workflow. Okay, uh, whenever you create a cluster in Databricks, so suppose if I just created a notebook, if I attach that notebook in the workflow, and if I selected a like a job cluster, so that particular cluster will be created only and only for my job. Once that job completed, that cluster won't be there. Okay, so this cluster I cannot create it and then directly use it. This will be there only and only for my job. Once that is job is complete, this cluster will end. So it's only for the job. Okay, we will right now create a or purpose cluster. Then this is like a just for machine learning purpose and all of that, so I'm not going through this detail. What is the Databricks runtime version? Databricks runtime version is basically the different. So suppose uh, just the upgrade of your overall Databricks environment and the cluster environment. So suppose here they create based on the Spark update, they create like a different version. Okay, so the most updated is 15.3. Suppose if I'm using a 15.3 version, and then I am, and in Databricks community edition account, you cannot create the like it will be a standalone cluster. You cannot create the worker node and all of that, but which we will create in the normal account. Okay, those things I will show you, but currently I am just creating a 15 GB memory cluster, not more than that. Okay, so here I am creating a cluster. Cluster is basically used for your computation purpose. So it will take some time to create your cluster, right? So the cluster is starting, and any kind of a processing, you cannot process anything in Databricks until unless you create a cluster. Okay, so first we are creating cluster, and then I will import my uh, notebook over here. So what I am doing, I will just click over here, and then I will click import, and I will import my notebook here.
Abhishek, you mentioned that, while creating the cluster, we basically decide that, okay, how much data we are going to import. For example, you mentioned that if we are importing to 20 gigabytes of a file like
Mhm.
CSV or maybe any format, then it should be ideally like, around 20 gigabyte of a cluster it should be there. But like if we have like multiple processes running at the same time or maybe parallelly, so how do we decide that, what will be the computation for the cluster, like in real time?
For cluster, how much will be the size of the cluster, and
Right.
how should we? Yeah, so I will come into those details going forward. So
Okay.
yeah, so as I told, yeah, so please be with me. Those things will
Yeah.
come. Yeah.
Okay. Okay, Abhishek.
Okay, so we basically imported uh, the the notebook, and then I am going to, yeah, so this is the particular notebook which we have imported. So if you open it, here you will get all sort of a code, right? So this is the batch process code which we will use for one of the project. Then aggregation in Python, aggregation in Scala, aggregation in SQL, Common operation is Python, Scala, SQL, delta table processing, okay, which we will learn going forward. So I'm going to the mount code, which is written in Scala, which you will also find in other language, like if you just Google it, but this is written in Scala. So if I open it, now what I am doing, suppose whatever like folder you want to mount, go to that particular, I'm opening my data lake. And I'm going to my storage account. And I'm going to shared access signature. So first of all, here I will give all the details. So I will attach a cluster first. And this code you don't need to remember, okay? So nobody remembers the mount code. So it's not needed that you remember the mount code. It's very easily available in the internet. You can easily get it. So here, go to the shared access signature, allowed all types, and then here you can give your expiry date, from which date to which date you want to give Databricks the access to reach out to storage account. So you can give the duration, and then you can generate your token key, which we will use in Databricks environment. So I will copy the SAS token key, and that SAS token key will be passed over here. So here we will give the storage account name. So this is my storage account name. We will give the container name. So suppose if I go over here, suppose, yeah, input container name. And then you will give the mount point. It's a general practice that we give /mnt slash, like the container name, but it can be anything. It can be /mnt slash xyz, it can be /mnt slash alpha beta gamma, it can be anything. But you should know, if you use this particular mount point, it's basically routing to input container name, which is this, storage account name, which is this. Okay. So it's up to you how you want to give it. Okay. If you don't want to give MNT, that is also your choice. But general practice is we just give MNT, which tells us mount. MNT means mount. And then if you want to give container name, then storage account name, that is also your choice. If you just want to give the container name, that is also your choice. Okay. So here, suppose if I'm giving the container name, which is input, and I will give input C, for example, because I feel input is already mounted in my case. So I'm just giving input C, and I will run this command. So it's basically using this particular key, and then it's hitting this URL, which is my data lake URL, which you will also you can see it over here. So it's web container name @ storage account name blob core windows.net, right? So this is the URL which it's hitting. Yeah, so it's basically hitting this URL, right? And then this is the config file, which is basically passing the SAS token key. And then we have done the mount. And then once you do the mount, you can basically, this is just a normal Linux command to %fs list the file. Yeah, so here I'm able to see all the files which is present in the input container. So ideally, if you go over here, you can see yeah, so you can see like percent department.csv loads db data lake, all the file you can see. Suppose if I want to see what's there in this, you can copy. Yeah, you can just write db data lake. Yeah, it will just list the file which is present inside this, right? So now this file is not moved to data lake. This file is still there in the sorry, this file is not moved into Databricks. You are still trying to read the file from the data lake itself. Okay. Now suppose if I want to read any of the CSV file which is present here, right? And this is a one-time process. So if you remember, we have given a SAS token key in a duration, right? From this duration to this duration. So you can reach out to this Databricks environment till that location. Okay. Now, one homework for you guys is here, try to find out. So suppose if I done the mounting, okay. Now I don't want to use this mount point. Okay, I want to use something else. Suppose if I want to use MNT / input XYZ. Okay. Now how I can unmount it? This is a homework for you guys. How to unmount this and mount it again, right? So if you just unmount it, then you can just run this code to mount it. Okay, so first is how to unmount it, and second, if I suppose I have done the mounting and suppose somebody came and also done the mounting, right? So suppose 10 people are doing the mounting, so how I can list all the mount point which is present in the database environment, that also you need to find out. So it's a very simple command for both of them, you can easily find out it. So yeah, so this is how you can mount it. This particular mount point will be valid not only for this notebook, it is valid across the notebook. You can ideally use this mount point anywhere in Databricks environment, okay, to basically read the file from the data lake for that much amount of a duration, okay, the duration which you have given in the data lake. So this is a one time process, not every time you need to do it. So not every time you need to run this particular command. This is a one time process until and unless there is a the security policy that you need to mount it again and again, so it's a different case, but it's a ideally a one time process, okay. Now suppose if I just copy this and I am going to
So mounting is basically a drive mount, right, Abhishek?
mount is basically a
Drive mount. So uh, could you please explain a little bit again on the mounting, something I
drive mount,
missed?
as in what you mean by drive mount?
Like for example, if we have like in it's like mapping the drives between two servers.
um, it's like, yeah, so you basically trying to from database environment, whenever you are trying to fetch the file using the mount point, it's basically routing to your data lake itself. From there it's using the mount point which you have created, which is this.
Yeah.
So it's a link. So suppose here whenever you are trying to uh, whenever you want to see what's present in the data lake, you are referring to this particular uh, mount location to see what files is present in the data lake. That's also, it's a connection. You can think it of think this as a connection. You're making a connection. So suppose here only you're making a connection that whenever I want to hit this, it's basically routing to input container over here. Input container over here.
Okay.
So
So
Abhishek, I mean, ideally, like this mount for any existing project,
mm,
this mounting process will be already done by someone else, right? We don't need to do anything extra like when we
no,
commit
no. So
project.
sometimes, yeah. So this particular process you need to do it. Yeah. So you will do it from your side. So mount point is generally being created by the developers itself. So sometimes suppose if you are starting a project, then the infra guys will not give you the mount point directly. They will give you the access token keys and all of the credential they will give you, but mount point you need to create it ideally. But suppose if you're joining a project which is already going on, then you might get it already, but you need to do it.
I mean, is it like user specific or it is common across all the users
Common
who are?
across. So suppose if I create a mount point that can be used by all of you if you are if we are working in a same project, so mount point is being created once, that will be used by all the developers. It's not like every developer will create a different mount point for themselves. It's not like that.
Okay, so like the similar approach do we need to do with the blob service as well, or is it
Yeah, so
different
same
thing?
process we need to do the blob service as well. There is no different process. So for blob service as well, you will get the SAS token key and then you will do the mount. And says
Okay.
token key is one of the process of doing the mount. There is other processes as well for doing the mount by using service principal, and for that I need to again go through intra ID and show you how to get a service principal. But there are some other processes as well, like few other processes as well, beside using the SAS token key. It's not the only process.
Okay.
So today we are looking at the SAS token key process of doing a mount.
And same goes for S3 bucket or any other environment, like any other cloud, right?
Yeah,
So
so
for
for
example,
S3
okay.
bucket as well, there will be a process of doing a mounting. But yeah, so there as well, you will have some sort of a key which you need to pass in data lake and then you need to mount.
Okay, Abhishek.
So yeah, so here I will suppose if you just want to read the data from this folder, right? Yeah, so here what I'm trying to do, I am trying to see all the file which is present in the input container. Okay, so these are the files present in the input container, department to employee data, right? Now, suppose if I want to read the file in a data frame, right? So whenever you want to read the file in pandas data frame, you write pd dot read csv. That is what you write. But here, what we are writing spark dot read. So as I told you, we are using a Spark API to read the CSV file. What does this particular infer schema means? Whenever CSV, so this you will never write whenever you are reading a Parquet file, right? So you will not write infer schema equals to true because it comes with the schema. See the Parquet file. So we will also understand what is the difference between a CSV file and a Parquet file. But CSV file, like you will not write it in the Parquet file and other files format, but CSV file you need to infer, you need to write infer schema equals to true. If you want to infer the schema, what does it mean? It will basically go to the file, it will see the data type of the your file, and then it will get the schema from your file itself. So it will understand that suppose in department id, if we have two column, department id and name, so it will check whether the name contains what kind of a data name contains, and then ideally by checking that, it will get the schema for you. So infer schema equals to true means it will check your file and get the schema for you. Header means you all know what does header means, right? So header is just like a header. If you write header equals to true, it will consider first row as a header. Separation means your CSV file is a comma separator file, so that is why we are giving this separation. And then load means here we are giving the file path. Okay.
So Abhishek, like you mean like infer schema is nothing but structure or what it is exactly?
It is a data type, so it will get the data type for your file format, whether it's a integer, whether it's a string, it will get a data type for you.
And we
That
don't.
particular column has what data type, it will get that for you.
Okay, and for Parquet we don't define it because it's a
We don't.
default schema, right? Like
So it
default
has a
function.
schema already existing in the file itself. So whenever the file Parquet file is being stored, it has a schema already defined in the file itself.
Okay,
It
okay,
carries the schema already. So
Okay.
Spark doesn't need to like do anything to get the schema. It will just get the schema from the file itself because it stores the schema. So suppose whenever you define the uh, table in SQL, there is a schema already defined in that particular table, right? So
yes,
similar to that in Parquet, your schema is already defined in the file itself. So you don't write infer schema, those
okay.
things over there.
So same
Enough.
goes with any other serialized data sets, right? Like Avro or
Yeah,
RC
in
or
Avro as
QRC.
well, it is
Okay.
defined. Yeah, so I mostly work with Parquet and this other file format. In JSON as well, you don't need to define it. But in so in CSV file we are defining it. Now when to define, when not to define. Okay, let's understand that. So suppose whenever if you write infer schema equals to true when you are reading the file, this we suppose when you're sure about it, right? So when basically you feel that in my particular department table, department ID and the name. So suppose here we have, here we have department ID name, and I am very sure that this will be integer always. This will be the text string always, right? So here I can ideally define my schema prior, and then I can utilize my schema over here, right? So that I will show you going forward how you can do it. So whenever you are sure about it, you define your schema prior and then you utilize that schema. That saves the power of the Spark. Reason being, if you do infer schema equals to true, it needs to go to the file and then read your data twice to get the schema first and then to read the data. But if you don't do the infer schema equals to true, uh, and then if you just define the schema automatically in your table, then in that case it will just go and get the data instead of getting the schema as well for you. Okay, so when you're sure about your schema, you define your schema. When you are not sure, when you feel that there are 100 column, I cannot ideally know what will be the data type of your table and all of that, in that case you just do infer schema equals to true.
Okay, Abhishek.
Now here you can see, right, spark dot read we are writing. So we are calling basically a Spark API. We are writing a PySpark code over here. One more thing which I want to highlight here, this particular notebook is created in Python. Okay, that is why I am writing PySpark code directly over here. But if you write a SQL code down below anywhere, you need to write %SQL. In this particular notebook, I can write all four languages. I can write Python, I can write Scala, I can write R, I can write SQL, I can write any of the language here. But whenever if you created a notebook in Python, you don't need to write magic command. So probably magic command as in. So suppose if I want to write a SQL code here, right? If I want to write a SQL code here, I need to write %SQL here to write any SQL code. %SQL if I'm writing a SQL code. And if I'm writing Python code over here, then I don't need to write any sort of like % command over here ideally. But if I'm writing any other language, then I need to write %SQL and then I need to write that language. Otherwise, it will not work. So suppose if I just write %SQL over here, it will consider the below language as a SQL language, and this particular command will not work in that case. So it's giving a error. Reason being, this is being considered as a your SQL code instead of PySpark code.
Okay, and if I change this like this notebook to SQL by default, right now it is Python, right? Yeah, exactly.
If you change it to SQL, then also it will not work. So this will not work if you change it to SQL. So
And then
and to
if I
run,
if I would like to write a Python code now, which is like you have written right now, then do I
so
need
you
to
can
type
write
percentage
%Python or
Python? Okay,
yeah.
okay.
So if I write %Python, this will work now.
And for Scala, like if I would like to write some code of Scala, then I
You
need
need
to
to
write
write
percentage fine.
%Scala. Yes.
Okay, okay. So within the same notebook, I can write different languages.
Yeah. Yeah. So you can write different language within the same notebook by just writing your magic command. So let me copy.
Magic command is what?
This is
What
magic command. We call this
Okay,
as a
okay,
magic command.
okay.
Sorry to use that term, but we internally it is being used as magic command. So I'm just saying that. Okay, so this is a magic command ideally. So now we have read this particular data frame in DF. Now I want to display, so I'm writing display DF. And also, if I will show you 1 second. So here you can see it got the schema for you, right? Integer string. Let's make it false. See, here this time it's just given by default string is string. It haven't got the schema for you, but if you make it true, it's getting the schema for you.
So Abhishek, just one thing, like for example, if we have a table with 100 columns,
Mm,
uh, you said like if we explicitly mention all those things, schema details,
mm,
it will have a impact on performance, right? So
yes.
like if that is the case, like is it recommended to do one-time exercise to understand what the schema for all the fields, or I mean in real time, like how it is to be done?
So
What is the recommendation?
generally, like the recommendation is to suppose for the raw tables, for normal raw tables which you have, you do the infer schema equals to true because you ideally cannot get the schema if that file is coming as a CSV file format. So you do the infer schema equals to true itself. But when you are dealing with very standard file format, which is like very standard files which you already know, department, employee, or like which has less column. In that case, you can define the schema and then read the schema for you. But in general, you do the infer schema equals to true. It's not like it impacts the performance in a like so huge manner that you need to spend too much time in. It's just like um, the better performance will be there if you just define the scheme, but it doesn't impact it in a so huge manner as well at the same time. So in general, we do the infer schema equals to true when you have many column and you ideally cannot spend time in analyzing all the columns. So it's not recommended to do that.
Okay, okay.
Yeah.
I mean, like how we have to mention the schema details here. For example, here in this particular code,
Yeah, I'm
in
going into that part now.
okay,
So
thank you.
yeah. So now here, so suppose if you want to read the CSV file, you can write CSV over here. Now, if you want to read the different file format, you can write JSON, Avro, like the other file format. You need to just change the file format over here, and then you can read other files as well. And suppose this particular options which is there over here, option, all of this option can be combined and then can be given as options, and then everything can be combined, just the way of writing it. Infer schema equals to true, header, separation, all can be combined and then load. Just do this and then run it. Now suppose if you have two file format, like two files having same schema, so you can give the first file and then second file and then read both of the file in the same table. That also can be done. All of this you can try. I will just give you the sample notebook, you can try it out. Now suppose in this particular folder, if you want to read all the file, department 1, department 2, and employee is not present, for example, and you want to read all the files, so you can just give department star as a prefix and then star, so it will read all the file starting with department, and then it will load all the file. Okay, so this also you can ideally try. Now if you want to define the schema for your files, there are two ways through which you can do it. First is this way, by using struct field. this ideally used over here, and also it can be used in the nested going forward when we learn about complex JSON. There, suppose in complex JSON you have like a particular array, and then inside array you have also a particular column. So for that we use a struct particular field to define the data type. Yeah, so in this way you can define the data file, the schema of the file, and then you can ideally say schema equals to schema defined, and then read the file.
So Abhishek, so what is schema? How is schema defined here? Like,
Yeah, so here we said department ID equals to integer, name equals to string type. So we said integer, department ID will be the integer, name will be the string type.
so this is like creating
So
a table.
yeah, so just like in SQL as well, you define. Currently, we haven't created a table. We just define the data type of the data I'm getting. So it will get in the same, like if you define the schema, it will read your data in the same file format, which is department ID as an integer, name as a string. But
Abhishek,
yeah,
what was the need of so if you go to that infer schema, so we already have done it, right? What is the like need of specifically defining it again?
so this I am infer schema is, so suppose if you say that I don't want to define the schema, sorry, I don't want to do the infer schema, I want to define the schema and then I want to read the file. So this is how you can do it.
Okay. So
Yeah.
alternative, like if we know all the columns data type
If you
and
know the
okay.
data type of the column, then you can basically use this. You can ideally uh, define the schema, and if you don't want to use the infer schema, then you can define the schema and then read the table. That is what I want to.
Okay.
That is what I mean. Okay.
If you have to read the table, defining a schema is not a must.
Sorry.
If we have to read the file,
Uh,
defining the schema is a must, or it doesn't have to be. It's an option.
it's an option. So if you know the so suppose in this case, ideally when I'm reading only my department file, I will just define the schema in that case because it's very straightforward. Department ID will be the integer, name will be the string. So I will define it in this case. Suppose if I'm reading an employee file having 10 columns, I will define it because I probably know every column. But if I'm reading a 300 file, like a table with 300 column, I will not define it in that case. Or suppose, yeah, so because I will do the infer schema equals to true in that case. So yeah, so you can just see when you can define it or when you cannot define it.
Okay.
But
Yeah.
when we are loading the data to the table in the database afterwards, after processing, it's good to have a definition, right?
In database, when you read the data from the database, so
No.
database has, yeah.
Basically, I would like to load the data now from this CSV to database table. So
Mhm.
basically, I will be creating a structure in the database table, right? So for example, department ID is integer and it's like nullable column. And then, for example, if I define it here itself, so I make sure that, okay, my database table will get the same data, what is being defined
It
here.
will not throw error. So suppose
Yeah,
here
exactly.
in
Yeah.
Unity catalog, when you create a table with a data type,
Yeah.
then if you define it and if you just write the table, write the data to that table, it will not throw error. Otherwise, it will throw error, as simple as that.
Exactly.
Yeah.
So it's basically good to go with this approach, right? Like over the infer schema, because infer schema, we don't know what kind of table will be created in the database
Yes.
afterwards. Okay.
Yes, so it has advantages as well, and also at the same time, when the table is big, yeah, you cannot define it, so you do the infer schema. So generally, guys, what happens is, So suppose if you have 300 column, ideally you do the processing in 10 columns or 5 columns, which is your important column, right? You don't basically do the processing in 300 column. So you try to process in 5 to 10 columns as well. For that, if you want, you can like define it and then process it. So it's not a hard rule that yeah, we will just do the infer schema true equals always, or it's a yeah, so you see when you can define it or when you cannot define it, but you will ideally create a table over here, and then whenever you're writing the data in that particular table, it will not throw error if the schema is proper. Yeah.
Right. So basically, like, if I don't define any infer schema and I have like 300 columns or 400 columns in the source, so better to go for a table which is like all string, or like with a defined as a string, so that I don't have to specifically define one by one. And
Sorry, I haven't got your question. Can you please repeat it again?
yes, yes. So Abhishek, like for example, I have 300 columns in the file. So, I mean, I specifically have to write for everything. Better to go for infer schema. And then while loading the data into the final table, I already have the columns. So I will make all of them as string,
So
right?
you can make all of, so when you are reading it, you can just read the table as a string.
Yeah,
And then when you are doing the transformation, you can define for the data type for the columns which you are using,
yeah.
and then you can write it. Yeah, so that also you can do.
Okay. And while defining this structure type, right? Like, so it's basically again going to be slow, right? Because we are
Why?
putting one more step. We are
No, no,
putting one
no.
more processing step.
Why?
Okay.
No, it's not like yeah. So when you're defining, it's actually a best practice to define schema of your table, and also like mention the DDL script of the table, which I will show you how you can do it. But
Okay.
it's good to
Good.
define it. Okay.
Okay.
So guys, I need to jump on a call. So what we will do, we will continue from here itself. We'll complete this particular notebook. I will anyways upload this notebook, you can run through it. So beside this particular struct type, some error is there, which yes, due to some syntax issue, or I will just try to complete this and then I will upload it. And then there is a other way of defining it as well, which is the schema alternate. So here you just need to pass department ID equals to integer, name equals to string, and then from by this way as well, you can define your schema. Then you can say, Abhishek, why when to use the struct field and when to use the this particular simple method. In the struct field, uh, when you want to define the schema for a column, and then inside when you are working with JSON and other things. So here you can like when you have uh, a particular column, and then inside that as well you have a column, right? So struct field is better in that particular case when you have nested column, right? But in this particular case you cannot define. So the struct field is commonly used because it's standard. It can be used for any kind of nested columns as well. This is a simpler way of doing it. Here we just say department ID equals to integer, name equals to string, and then we use it over here directly and then read the data. So yeah, so this is what I wanted to cover, but I will just run through it once again tomorrow. If you have any question, you can ask me tomorrow, but I need to jump now because I am anyways 5 minutes late. So let's continue from tomorrow onwards, and I request each one of you to join on time, because I will start on time and I will finish on time, because for yes, everybody has a schedule, right? So please join on time, so that we finish on time, because sometimes you join 10 minutes late and then I need to start 10 minutes late as well. So please join on time, okay? And tomorrow I have a meeting till 4:30 my time, which is so that tomorrow I will start at 8 p.m., not 7:30, but 8:30, 7:30 or 8 p.m. confusion I will clarify in 1 or 2 days and we'll fix the one timing. But tomorrow we'll connect at half an hour late, which is 8 p.m. we'll connect tomorrow. But till give me some 2 to 3 days of a time. We will finalize the time 8 p.m. or 7:30. But for now, 7:30 is a standard time. 8 p.m. we will connect tomorrow. And Wednesday there won't be any class. Reason being, I go to office. So I already informed all of you, I guess. Wednesday there won't be any class. like this week and going forward as well. So Wednesday weekend there's no class. Tuesday sometimes I go to office. This week not going to office, but going forward once in a month or twice in a month I go to office on Tuesday. So on Tuesday and Wednesday there won't be any class in that case. So tomorrow we are connecting at 8 p.m. IST, half an hour late. Okay, so let's meet tomorrow. We'll run through this notebook and also we'll continue forward tomorrow. Thank you so much for your time. See you then. Bye.
Thank you, Abhishek.
Thank you.